So what I'm going to do right now, and you can do this if you want, is write our equations at the top of the page. First we have momentum is mass times velocity. That's how it's defined. Then we have impulse. Now the way we write impulse, or change in momentum, is we use our delta, our change in, and there's two ways to find that. The first way is mass times change in velocity, although above that you may see it expanded. I'm going to write it as mv final minus mv initial. In fact, Matt, that's usually the one I jump straight to because that's more plug and chug. I usually don't write I write the shorter one because it's shorter, but when I'm calculating, I go straight to the longer one. You see those are both interchangeable. Change in means final minus initial. It's the change in velocity, so it'll be mv final minus mv initial. Or that. We talked about how if you're stuck with the same impulse, the same change in momentum, and you specifically in car accidents, well, in any car accident, what's your final momentum always? 0, right? Because your final velocity always is 0. Okay, we can come up with that. Or if you want to replace car accidents with something less terrifying, in any tackle, what's your final momentum always? 0. Your initial momentum for a car accident is going to be really your mass times your initial velocity. And engineers are stuck with your initial velocity. Your initial velocity, Sarah, is either speed limit, or if you're stupid, faster. How the heck can we help you survive a car accident? We look at this version of impulse. We look at this version of impulse, and we say, well, if we can make time bigger, force has to get smaller. And in fact, it's the force that does damage in a car accident, not the actual impulse. It's how fast you have to absorb the impulse. Longer time, smaller force. So let's start calculating some stuff here. Example 1. Matt, what does example 1 part A want me to find? And don't say magnitude. The word magnitude just means size.
Change in momentum.
What's another word for change momentum? Begins with letter I. Impulse. Okay? So you ready? As soon as they say find the change in momentum, Matt, the first thing that I do is I write that down. But there's two ways to calculate that. I can either calculate that by going mv final minus mv initial, or force times time. And the one I'll use is determined by what they gave me. Look at the question. Did they give me two velocities, or did they give me a force and a time?
Force and a time.
I'm going to use this one. By the way, Jaden, eventually I'm going to get lazy and I'm going to stop putting a delta in front of the time, because time is always a change in. We've done this before where I said, time is always a change in, and so we kind of just over the years get sloppy and stop putting a delta in front of it. But for now, because there's a delta on the left side, I'll put one on the right side too, so you see a change in equals a change in. Hey, Matt, what's the force in this question?
8 newtons.
Good, finding the units, yes. What's the time in this question?
10 seconds.
In your head, Matt, without using a calculator, 8 times 10, what's the change in momentum? 80. What? Well, there's two ways to measure change in momentum, 2 units. There's kilogram meters per second, or in this case, just because I used force times time, I would write the units as Newton seconds. But if you wrote kilogram meters per second, I'd give you full marks because it is momentum. I did say last lesson that Newton seconds and kilogram meters per seconds mathematically work out to the same units. Hey Matt, what's B want me to find?
Magnitude.
No, magnitude means side.
The object's impulse.
Impulse, what's another word for impulse, folks?
Change in momentum.
Do you notice I didn't leave you any room for part B? I did that on purpose. You don't need any room for part B. What's the answer to part B? Change momentum and impulse are the same. Really, all I'm testing is, do you know that impulse and change momentum are the same thing? It's going to be 80 Newton seconds or 80 kilogram meters per second. Matt, what's C asking me to find?
Change in velocity.
I'll use that one. Because I think change in velocity is that delta V. How would I get the delta V by itself?
Divide the V out. And
I want the V to stay. I want to get it by itself.
to stay, then you divide the M.
Yes! Folks, on the same line, are you okay? I'm going to go like that. Okay? So, Jaden, we're going to get this. The change in velocity equals delta P. Matt, what's delta P?
Delta P. Divided before. No. Oh, 80?
Yep. Not. Can you say it with authority and confidence in your voice? So instead of saying 80, how about give me a deep, confident, what's delta V? Sorry, delta P.
80.
What's another word for delta P? Change in momentum or? There you go. So you're saying 80? Yep. And the question told you the mass up there somewhere. What's the mass?
4.
In your head, can you do 80 divided by 4 without a calculator?
20.
With authority and confidence in your voice.
20.
That's the change in momentum. Change in velocity, 20 meters per second. Matt, here's what that means. If you started out going 2 meters per second, you're now going 22 meters per second. That's a change of 20. If you started out going 17 meters per second, you're now going 37 meters per second. That's a change of 20. Or, if you started out going 5 meters per second south, and now you ended up going north, what's your velocity? If you have a change of 20. If you started out going 5 meters per second south, and you end up going north, what's your final velocity?
15.
15 north. Or, Matt, what's D asking me to find?
Initial velocity.
What did I find in part C?
Change in velocity.
I wonder if I can use part C to find part D. I wonder if I can go change in velocity. Folks, what's change in anything? Perfect. Cool. Okay, there's VI. What's right in front of the VI? I don't like that. Wait a minute, we've done this dance before. I'm going to go plus this to that side. At the same time, I'm going to minus this to that side. We did this in forces as well. Yes? The same trick. We're going to get this. The initial velocity is going to be, the final is going to drop down like a domino, minus the delta V. Is that okay, Sheldon? We swapped the two terms, basically. One became positive because it was originally negative. The other one became negative because it was originally positive when it moved sides. Hey, Matt, what was V final according to this question?
V final is 12.
Yep, minus. What was the change in velocity?
20.
In your head, what's 12 take away 20?
Negative 8.
So we could write this, or if the final is 12 north, what would negative 8 mean in terms of a direction?
8.
And this is why, Courtney, you see me always putting the vector signs on here. I won't take marks off if you don't. It's me reminding myself, be careful with directions. Let one way be positive and let one way be negative. And if I get a negative, it's the opposite direction. Is that okay? I would argue, Rebecca, I didn't do a single new thing there. I used that impulse equation in all of its forms cleverly and creatively. And that's all we're doing for the rest of this lesson. Example 2. Courtney, what does A want me to find in example 2? Change in momentum tells me I'm going to write delta P. There's two ways to find change in momentum. One has a force and a time. One uses a final and an initial velocity. Which one am I going to use, Courtney, in this question? And the initial velocity. See it? Okay. The other way I know, what is B asking me to find? Magnitude, folks, just means size. That's not what I'm asking you to find the physicsy term. Everybody says, it wants the no, it wants the, by the way, the reason I keep saying magnitude is that's my way of saying I didn't put a direction in, so as a vector, I'm just asking you to find the size of the force. You know what? If they're asking me to find the force, I wouldn't be using the force to find the impulse. In fact, you know what? I'll bet you I'll use my answer from A to find F force, because there is also a version that has an F in it. See how we're kind of going full circle, kind of repeating over and over? Okay, so yes, that's the written out version of M delta V. Courtney, what's the mass? What's the final velocity? Minus, what's the mass again? Pause. Look at the final velocity, look at the initial velocity. Does this question suggest that there was a change in direction at all? Is there like one north and one south, or is one east, one west, or is there a rebound? No. No. So, you know what? What's the initial velocity? It'll be positive 2. Okay? If there had been a change in direction, I would let one of these be positive and one of these be. Okay? But get in the habit of checking. Don't just start to plug and chug. Read the question. Now it's plug and chug. Can I do this one in my head? It's going to be 315 times 15.5. Yucky numbers. No. You can try this on your calculator yourselves too, of course. 350 times 18 minus 350 times 2.5. And I get a change in momentum, or an impulse, of 5,425. 5,425 what? You could say Newton seconds. I'm going to go kilogram meters per second because, Courtney, we used mass velocity to find it. Again, though, if you wrote Newton seconds, I'd give you full marks. In fact, every year I have a couple of kids, they just always put kilogram meters per second for everything, and that's fine. I'm going to be a nerd and try and get the context right, though, because, nerd. Courtney, what's B want me to find? Don't say magnitude. Huh? Force. What did I find in part A? You know what would be cool? If there was a version of impulse, of change of momentum, that had a force in it. Is there? This one. That's also another way. Quickly, money. How would I get the F by itself, Court? Divide time. So if I hear you, it's going to be that. I got sloppy. I didn't write the change in, but yeah, it's going to be divided by T. What was the impulse, Courtney? 5,425 divided by. Is there a time? What? Oh, okay. 1 minute. By the way, if they had given you the time, Alex, as 1 minute, please convert it to seconds. So it's going to be divided by 60. The average force looks like it's 90.4 newtons. I pause, and again I say, Sarah, I don't think I did anything new there. I just gave you another way to start at this version of impulse and end up at this version of impulse and find whatever. And that's the theme of today. Multi-step questions. Next page. Sarah, what's she's turning the page. No, Sarah, what's example 3 asking me to find?
Final velocity.
The final. Now, normally I'd go VF, VI, AT, but you know what? I think we can get there in one fell swoop. I think. Did they give me a force, Sarah? Did they give me a time? Then I think I can do this. impulse, yes, equals impulse. Okay? Impulse equals impulse. What did you say they wanted me to find, Sarah?
Final velocity.
That guy right there. Oh, I guess vector, vector, vector. Fair enough. How would I get the VF by itself? Well, I would move this over first, Sarah. How could I move this here thing over?
Add it.
So if I hear you, you're telling me force change in time plus mv initial equals mv final? Yep. How would I get the v final by itself?
Divide by m.
Can I just do this on one line without rewriting it? Okay. Now, some of you may have noticed that there is some shortcuts I could have taken, because one of these is 0, and I ignored that just to show you, Sarah, here is an equation we could derive if things weren't 0, but it turns out one of these values is 0. Which one?
V initial.
So, I could do that. Okay. The final velocity is going to be the force. 2.3 times 10 to the 4th. Time. 120. If the initial velocity wasn't 0, it would be plus the mass times the initial velocity. Don't need to. Divided by 2.6 times 10 to the 4th. Again, you want to get comfy with scientific notation. And I get V final of 106, is that right? Yeah? Point blah blah, I'll go 106 meters per second. Again, Matt, I would argue I didn't do anything really new there. I took impulse equals impulse, as opposed to impulse equaling one of, you know what? I let these two equations equal each other since they both equal impulse. Okay. What else can we do? John, what's example 4 asking me to find?
The force.
Force. I could solve this by saying, for everybody to get the obvious one, win or minus, but we can get there in one line by recognizing, John, did they give me a time?
Yeah.
Then I think force is what they asked me to find, and there's a time. I think I can use impulse to get there. I think, again, I could say impulse equals impulse. Wow. Did the screen just go black for you guys?
Yeah.
Okay, it didn't do anything on my screen. I can still see. Is that okay? Are any of these 0?
Yeah.
Which one, VI or VF? I'll give you a hint. You're half right. One of them's right. VF, we're coming to a stop, so I can go. Is that okay, John? John, what's this question asked me to find?
The force.
How would you get the force by itself?
We divide the P over.
The force is going to be negative mass times VI over T. It's going to be negative mass times VI over T. What's the negative here telling me? The force is in the opposite direction that the car is traveling, which makes sense. To slow down, you better have a force backwards. Oh, you know what? I can do this in my head, I think. The 1.6 and the 16 will cancel. 32,000? Negative, sorry, negative 32,000? Negative 32,000 newtons. And I would argue, John, that's probably a little quicker than trying to draw everything in free body diagram, get the that stuff. And I would also say, did I really do anything new there? No, I said impulse equals impulse. And solved what they gave me. Example 5. Prith, what does example 5 want me to find? Did they also give me a time?
Yes.
Let's see if we can solve this using impulse equals impulse. Let's go impulse equals impulse. Are any of these 0? Well, when we drop a rock, what did we say we can always assume if we're dropping a rock? So, it's going to be m v final divided by time. Do I know the mass, Prith?
Yes.
Yep. Do I know the time?
Yes.
Do I know v final? Urch. No, it's after it hits the ground. Then, by the way, then you would get a force of 0. I assure you, when you hit the ground, you feel it. Do I know v final? And this is good review. What did you say VI was? What else has this question given me that I haven't used yet? How big?
40 meters.
Nope, 40 is wrong.
Oh, negative.
Why negative 40?
It's down.
We're ending up below. Did that flicker again?
Yep.
Okay, I bet you my bulb's on its last legs. Oh, okay. We're ending up below from where we started, and have I gone on my rant about how vectors and change in direction now has become, again, much more important, unlike winner minus loser, where we could just decide what was positive and go with it, okay? So, negative 40. Oh, I know one more thing. Negative 9.8. I can't use t as 0.35. That's the stopping time, not the falling time. Looking for an equation, Prit, that has a VF, a VI, a D, and an A in it. There is one.
Yep.
Which one?
VS squared equals VS squared plus 4D.
Good. Oh, and Prith, I can do this, yes?
Yep.
And how do I get rid of a squared?
U square root.
I think that's going to be V final. V final is going to be the square root of 2 times negative 9.8 times negative 40. This might work out evenly. This might work out nice. I think it will. Square root. And I get 28. Is that okay? By the way, the force of impact, what direction is the force of impact? When you hit the ground, which way does the ground apply a force? Up. I could bring in, like technically I could say this is supposed to be negative and whatever. You know what? I'll just track and I'll say at the end, force, it's gotta be up. I've hit the ground before. I'm pretty sure the ground pushes me back up because it hurts. Is that okay? So Let's move it over, plug and chug. It's going to be 2.5 times 28 divided by 0.35. Oh, this might work out nice too. It's going to be 7 divided by 0.35. It's the same as 70 divided by 3.5. 700 divided by 20? 200. 200. Gah, I was off by a decimal. And it's a force, newtons, and let's add a direction, up. I stuck that in because, Matt, are we getting towards the end of the year? We are. Hey, quick review of some free fall. Have mentally jumped on in here? Shut up, Mr. Dick. Okay. Couple more, we're done. You ready, Cohen? Feeling good? Feeling lucky? Cohen, what's example 6 asking me to find?
Final velocity.
V final. Cohen, does this question give me a force?
Yeah.
I think I'm going to find this using impulse. I don't think I'm going to go VF equals VI plus AT, in part because there's no A. I don't see a meters per second squared anywhere. Okay? So I'm going to start out by saying impulse, force times time, equals impulse mv final minus mv initial. Just pick up from here, kiddo, okay? You get the stuff you missed. So example 6. Letting those two equations equal each other since they both equal impulse. What did you say this question asked me to find?
Final velocity.
You know what? Let's get this by itself here. How would I get the by itself? Well, first I want to move this over. Right?
Yeah.
How?
U plus.
Yep. So the F delta T drops down like a domino, but there's going to be a plus mVI, and that equals mVF. Good. Oh, Cohen, how would I get the VF by itself now? How would I get this guy by itself now? How will I move this over?
Oh, divide by
Oh,
n.
yeah. And are you guys again picking up? Here's yet another equation that hopefully you don't need to memorize. You can derive. Yes? I'm going to do it on the same line if that's okay. Are any of these 0? I don't think so this time. I checked. But now we are at the plug and chug stage. VF is going to be, hey, Cohen, are there directions in this question?
Yeah.
Does there appear to be a change in direction in this question? In other words, do you see an east and a west or a north and a south? Yes?
Yeah.
Then you better let one way be positive and one way be negative. Pick. What do you want to let be positive, east or west?
East.
Okay, so I'm going to do this. I'm going to put a plus sign there, a little plus sign in front of the 4.65. I'm going to put a minus sign above the west and look up, Cohen. I'm going to put a negative in front of that force because it's west. Yeah. So now let's plug and chug. VF equals F. What's the force?
390.
Nope. Cohen, what did I just put in front of that force? Look up.
Oh, minus.
What? Oh, okay, don't do that. I guarantee if this is multiple choice, I'll have the positive 350 answer kit. In fact, I'll probably put it as part A to pick from. What's the force? You're right, Cohen, say it now.
Negative 390.
Good. What's the time?
0.0.
Should the time be negative? Scalar, right? Times a scalar, doesn't matter, okay? So 0.075, good. Plus, what's the mass?
4.24.
4.2. What's V initial? And make sure you get the sign correct. It's in there in the question.
Positive.
Yep.
Or
Yep. Okay. See it all comes together? Divided by m. Oh, what's the mass again? Yep. Cohen, is this a fraction? Yeah? Is there more than one thing on top of the fraction? Yeah? Brackets. Is there more than one number on the bottom of the fraction? So you don't need to put the bottom in brackets. Again, this is an opportunity for you all to practice the calculator. This might work out nice. I think. Yeah.
Can I go to the bathroom look like a bunny?
Swift like a bunny. Sure. Quick like a bunny. Cohen, I got negative 1.6. What direction is that negative telling me? Ah, there it is. Okay. So I got VF equals, I'll write negative 1.6 meters per second. I'll put an equal sign and I'll say 1.6 meters per second west. And the reason I knew I had to write it this way is in brackets. Courtney, what did it say in brackets in the question? Magnitude just means size and direction. There it is. Now, Matt, you might have let west be positive and east be negative. Totally fine. You would get the same answer, but you would get your answer as positive 1.6, and then you would zoom out from the question, and you would say, what did I let be positive? Oh, west. We'd all get west. Okay? I totally botched number 7. Number 7 is a nice question. I totally did not leave you enough room to write in number 7. So you're going to write some of it in this area, and you may have to kind of write some of it like down here somewhere as well. I don't know. Sorry. Again, if you flunk the course, I've fixed it for next year. Ryan, what's A want me to find? Example 7, part A, what's it want me to find? What's another word for impulse? Or another phrase for impulse? Help me out, folks. What's another phrase for impulse? Change in momentum. Okay? You need to memorize that. What's another phrase for impulse? In other words, for part A, I'm going to write that. There's 2 ways to find that, my friend. Using velocities or using forces. Look at what they gave me in this question. Am I going to find this? Did they give me a final and initial velocity, or did they give me a force and a time? Okay, so I'm going to write mv final minus mv initial. Are any of these 0? Okay. Can we all agree that for any gun, the initial velocity of the bullet is always going to be 0? So here I said from rest, I may just give you a gun question, because guns are great examples of impulse and change in momentum. Let's assume the gun starts out with the speed. The bullet starts out at rest. Is that okay? What's the mass? Ryan, be careful. Don't say the mass is 12, because it's not. Look up, Rye. Is the mass 12? Why? Because I gave you the mass in what units? If the mass was 12 kilograms, that's a bowling ball sized bullet. We would call that a cannon, not a bullet. 12 grams. I'm also trying to sneak some reviews, so here's some unit analysis. Hey, how do I go to kilo? What do I divide by? I heard someone say it. Divide by 1,000. So 12 divided by 1,000, I think, is 0.012. Yes? What's V final? And I get, oh, I can do that in my head. 3, yeah? Should be. Yeah. 3 what? Units. It's a momentum, impulse, kilogram meters per second. Okay? There's A. Sorry. This is why I want to turn the touch screen off, because I'm used to being able to scratch stuff off the screen and get gunk off. Anyways, don't do that. Connor, what's B asking me to find?
Force.
What did I find in part A?
Impulse.
You know what would be cool if there was an equation that had force and impulse in it? Well, there is. Connor, how would I get the force by itself?
5/10.
So, the force is going to be the impulse divided by the time. What's the impulse? 3. Problem, Connor. You're looking. What didn't they tell me? What example is this? Still number 7. We need T. Well, when in doubt, I start to defic. I list my data. I know VI was 0. I know VF was 250. Connor, what else did they tell me that I might be able to use to find a time?
The like barrel.
I don't have a length as a variable. What variable? Oh, they give me D? What's D?
28.5.
Positive or negative? I think the bullet travels forwards. Positive? Yes? Is there an equation that has those 4 in it? Turns out there is. It's the one we hardly ever used way back when, from before Christmas. It's one of your DVT. It's there. We didn't use it much. Which equation?
It's the half.
Read it to me.
D equals 0.5
A half.
half VI plus VF.
Kevin, we hardly ever used that one, but it was on your formula sheet. We used that one to derive D equals VIT plus a half AT squared, to be perfectly honest. Oh, and what did you say VI was?
0.
So that's gone. What are we trying to find?
T.
Okay. I guess I would divide by 1, although is that going to make a difference at all? No. How will I move that 2 that's on the bottom over? What does on the bottom mean? Timesing or dividing on this side? Dividing. So dividing by 2 on this side is what on this side?
Multiplying.
Okay, so I'm going to have a 2 and a D. What's this VF doing to the T?
Multiplying.
How will I move it over? Apparently T is going to be 2 times 0.85 divided by 250. 2 times 0.85 divided by 250. No, wait a minute. I'm going to say that seems really small. No, it's a bullet traveling a rifle barrel. I think that would be a really small amount of time. I'm good with that. I was going to freak for a second, but then no. Oh, let's go pretty fast. Get 0.0068? Anybody else? Seconds. And now, I can go plug it in up here. Yeah. Quickly, money. The impulse is going to be, the force is going to be 3, the impulse, divided by 0.0068. And I get 441. 441 newtons. Along the barrel, I think, in the direction the bullet traveled. I'm pretty sure a gun pushes a bullet forwards, not backwards. By the way, a little bit of review. So the gun applied 441 newtons to the bullet. What did the bullet do? How big is the force that the bullet applied on the gun? 441, right? Newtons. Forces come in pairs. We're nearly done. Got a couple of thought questions, and then you get the rest of class. So about probably 5 more minutes. Here's the first one. I want you to consider the diagram at the right. Lydia, in case A, first of all, both cars are identical. Both cars have the same VI, 5 to the right. In case A, the car hits the wall and bounces backwards at 4 meters per second. In case B, the car hits the wall and comes to a stop. And then it says, assume the collision time for each collision is the same. So T is not going to be a variable that we need to worry about. In which case, part 1, in which case does the car experience the greatest momentum change? Case A, case B, both the same, or we need more information? In which case does the car experience the biggest momentum change? Hey, this is a chance for us to vote. Once again, how I hold your hand up is how sure you are of the answer. So looking at this, situation A, situation B, which one of these has a bigger change in momentum? Who says, gotta be A, Mr. Duke, it's A, gotta be A. 1, 2, 3, 4, 5, 6, 7, 8, and then a peer pressure. Was that yet or no? No, okay. So we have 9. Who says, no, Mr. Duke, B, come to a stop, B. 1, 2, 3, 4. Who says, C, both same? Who says, D, we need more information? So 9 of you out of 28 of you voted. Cowards! Are you awake? So those 9 of you, or those I think 13 of you, 9 and 4, 13 of you voted. Half of you, about. You can attack someone else's answer as being wrong or defend your own answer as being right. Attack or defend. Convince me. Yeah. What'd you vote?
A.
Okay. Convince me.
The change in velocity is bigger on an A.
What's the change in velocity in A?
-9.
Or positive 9, depending on which way you let me pause. 9 as a magnitude. 9. What's the change in velocity in B? 5. Momentum is mass times change in velocity. Sorry, impulse is mass times change in velocity. Lydia, which one has a bigger change in velocity, A or B? Which one has a bigger impulse, A or B? Everyone has to vote for the second one. In which case does the car experience the greatest impulse? Who says A? Who says B? C? D? Why is the answer the same as part 1? What am I really testing with that question? Why are these answers the same? I'm asking, do you remember that impulse and change in momentum are the same thing? If for some reason you had voted differently, I'd be saying, wait a minute, you forgot impulse is change in momentum. The impulse encountered by the 800 kilogram car in case A has a magnitude of, well, the mass is 800. And the delta V, what'd you say it was, Connor?
9.
Or -9, depending on which way you decide to make your directions. But you know what? That has a magnitude of 7,200. Yes? Okay. Versus the impulse with car B would be 800 times 5, 4,000 kilogram meters per second. Which car experienced a bigger force? Well, since the time was the same, but the first car had a bigger impulse, it must have experienced a much greater force. That allows us already to generalize. Example 9, which type of collision is worse for a passenger? Assume the initial velocities and the time of impact are the same. What's worse, if you have a head-on collision where the two cars stick together, or if you have a head-on collision where the cars bounce apart?
Bounce apart.
Why bounce apart? You're right.
Bigger change in velocity.
Bigger impulse, bigger change in momentum. And remember, we said this, change in momentum is force times time. What does the question say about the time of impact for each situation? The same. So how can I get a bigger impulse? If t can't get bigger, which variable in that equation has to get bigger?
Force.
Bigger force. Bigger force. Okay? Nice coloring there, Alex?
Having a good time.
I know. Here's one with some numbers. So it says, the diagram below depicts the changes in velocity of a ball that undergoes a collision with a wall. Indicate which case, A or B, has the greatest change in velocity, the greatest acceleration, the greatest momentum change, and the greatest impulse. All right. Okay. Can do this. Jaden, what's the first thing they want me to find? What's a delta stand for? Change in. What's change in anything, folks? Okay, so for A, I'm going to go V final minus V initial. Yes? Case A, case B. What's the final velocity of case A? 5? What's the initial velocity of case A? Don't say 10. Not if you let V final be positive 5. Then what's the initial, so Matt, if you let final be positive, then what's the initial velocity?
It's gonna be negative.
Has to be. By the way, Matt, what's the minus minus the same as?
I think.
So 15? Yes? Now, we're not going to change systems. Matt has decided to let final be positive and initial be negative. Let's do that for the whole question then. Let's look at situation B. What's the final velocity? You said positive, 28, minus. What's the initial velocity? What's a minus minus the same as? 28 plus 30, that has a change in velocity of 58. I'll add units, meters per second, meters per second. So which has the biggest change in velocity? A or B? What might a lot of non-physics people say? They might say, well, A is 5, B is 2, right? Have I convinced you that that's not the case? Vectors matter. Explanation we did down here. Okay? Is that all right? Yeah. We're good? We're awake? Excellent. Hey, Lydia, what does the second thing want me to find? You know what? Acceleration equals that. It's VF minus VI over T, but that's changing. Does it say that the time is the same for both questions? Which one has a bigger change in velocity? Which one has a bigger acceleration? And for the explanation, writing that, I think we can reason our way there. Yes? Trevor, what does the third thing want me to talk about? I got to be really fussy, not quite the momentum, because there's something in front of the letter P. Okay? Change in. If it just says momentum, it's mass times velocity. Change in is final minus initial, or, well, I can write this. Yes, Trevor? And it does say the mass is the same for both. Yes? Which one had the biggest delta V? That's what we answered in the very first question. Which one has the biggest impulse then? Which one has the greatest, Trevor, I'm going to stick with you, which one has the greatest F times delta T? What did you answer in part C? This? Did you look at your answer from part C? By the way, if you haven't figured it out yet, for a lot of these questions, if you're stuck, look at the previous thing you answered. What did you just answer in part? What's this a symbol for? You know another way to calculate change in momentum? Another way to calculate change in momentum is that. Remember what we wrote at the very top of the first page? This is all coming full circle. So, which one had a bigger change in momentum for part C? What did you answer for which one has a bigger change in momentum? Which one has a bigger force times time? And since the time is the same, which one experienced a bigger force? Got to be B. It didn't ask that, but that's a good follow-up question. Homework. First of all, can you please fix the answer to question number 16? The answer to question number 16 is 44. Did I show you the video crumple zones and cars?
No.
We'll stop motion? Okay. I'll open next class with that, and I'll also show you a video of a nice smart car crash as well. So your homework is, all of these, you need to practice this. You got 20 minutes. You can get it done.